This is an ordinary running jacket. You can buy one just like it almost in any sports shop today. It's lightweight, it stretches, it repels water, and when you're done with your run, you chuck it in for a wash and pick it up again for your next run. Every time you wear a running jacket, you're wearing a product built almost entirely from fossil fuel derived materials. The nylon that gives it structure, the polyester that lines the pocket, the elastane that makes it move with your body. Materials that work brilliantly on the trail, but it comes with a hidden cost most of us never see. It's in the chemistry used to make it, it's in what it releases when we wash it, and in what happens to it when it's worn out. This is Clear Run, a 3-part series that takes an ordinary running jacket and asks a single question. What would it look like if we rebuilt it from scratch without the petrochemicals and toxins that are so commonly present? Across 3 episodes, we follow the running jacket from its fibre and fabrics all the way to the end of its life, meeting the innovators who are radically rethinking each layer, the materials, the chemistry, construction, care, and recovery. Clean Run is inspired by the Performance Without Toxicity exhibition, exploring sustainable and circular innovations in performance wear, and in this series, we will dive deep to unpack some of the solutions that are showcased here. The exhibition is curated by Mills Fabrica in partnership with Goldwyn Innovations. It is open until 26 June 2026 in London. So if you're in the city, please don't miss it. You will absolutely love it. It's fantastic. I'm Mili Tharakan, and this is No Ordinary Cloth, where we stitch together a rich tapestry of innovations bubbling up at the intersection of textiles, emerging technology, craft, and sustainability. Join me today for a glimpse into the future of performance wear. Today, we start at the very beginning, looking at the various fibres and fabric this jacket is made from. And joining me are 3 young innovators who are taking one of the most stubborn corners of the materials industry, the fossil fuel-derived fibres that have powered activewear for decades, and that have gone largely unchallenged until now. These 3 radical disruptors are cleaning up sportswear from the ground up. Hitesh Manglani, Jen Bigon-Lur, and Korcheska Batyrova, welcome to No Ordinary Cloth. I'm thrilled to have you here. I have so many questions for all of you, but before we dive in, let's do a quick round of introductions. And since you're joining in from 3 countries, let's do a 30-second little trip around the world and introduce ourselves. Jen, I know you're based in London, but currently you are somewhere much warmer and lovelier. Tell us where you are and give us a quick introduction to yourself and Tiramira.
Hi, Mili. Thank you so much for the invitation on this podcast. I'm very excited. And yes, I'm currently in Singapore. And yes, I'm a French woman living in London for the past 7 years and was always very much interested in tackling clothes waste. And that's kind of from conversations and, experience stumble into understanding the problem with elastane. And that's why now with Tiramira, we are turning seaweed into stretchy fibers to replace that elastane that blocks our place to be recycled and are, of course, dependent on fossil fuel.
Brilliant. And what's the weather like? Tell us what temperature it's there.
Right now, I think it's around it's the evening, but during the day it was about 30 degrees, 28, very humid and
wow.
and sweaty. It's been a while.
I know it's midnight there, so thank you for joining us, and we'll try and not keep you up too late or early into the morning. Great. So moving west, flying well past and over London, we go quite far up north this time, now to Korcheska. You have probably just had your breakfast and starting your day. Tell us where you are and give us a quick introduction to yourself and Ozone Bio.
Hello, everyone. My name is Korcheska. I'm CEO and co-founder of Ozone Bio. We're based in Calgary. It's a city in Alberta. We're a Canadian company. What we do, we start with wood waste and nutshells and upcycle them into the new product stream. Our first hero product is bio-based nylon 6/6, high-performance material that's used everywhere, from the textiles to car parts. And we're the only company in the world producing it out of the nutshells and the wood waste. We're currently at the 1 ton scale per year and successfully passed all the trials in the textile industry, and excited to bring our bio-based nylon into the high-performance outwear very much soon.
Excellent. And what's the weather like in Calgary?
You'll be surprised. Today is like plus 10, plus 11. It's nice.
Brilliant. Okay, now moving a little bit further west, but more south, we have Hitesh, who has made an early start on a Friday morning for us. Hope it's not too early for you. Tell us where you're based and give us a very quick introduction to yourself and Supercarb.
Thanks, Mili. Great to be on this podcast. Thank you for inviting me. So my name is Hitesh Manglani. I'm the CEO and founder of Supercarb. We are a California-based material science company. We are basically upcycling sugar molecules from seaweed and citrus peels into high-performance fibers. These fibers have very unique properties. They're they are flame retardant, antibacterial, fast drying. So they have the ability to eliminate a lot of toxic chemistries, and they don't rely on petrochemicals that most of these, sportswear jackets are made of. I actually come from a textiles family. My dad has been running a retail store for 35 years. And so I've a very deep and personal relationship with this field. I grew up with his inventory in the bedroom I slept. And so, yeah, I'm really excited to be building this company. And so far, the journey has been pretty rewarding. Of course, it's very challenging, but, rewarding at the same time.
Excellent. We're going to dive into all three of your materials and what they're all about, but love it. Great start. So each of you bring a different ingredient to the table, right? One that could potentially find its way into a running jacket in the future. So I went to the high street and picked up a popular running jacket from a very well-known brand. And I thought we'd use it as our anchor for today's conversation and a way to understand what your materials could replace and what that shift might mean for how performance wear is made in the future. So here are the different materials that was listed on the label of this particular running jacket. So on the body, there were three parts. The face, which had 85% nylon, 50% elastane. The middle, which was 100% polyurethane. And the back, which was 95% polyester, 5% elastane. Then it had the side panels, which was 82% nylon, 18% lycra elastane. And the pocket lining was 100% polyester that was recycled. So I'll admit, this was the first time I've ever really looked so closely at the label of a running jacket. And it really genuinely surprised me. There were so many different fabrics at play here, layered on top of each other, and I guess each doing a very specific job. I was really pleased to spot the recycled polyester in there, but it was only used in the pocket lining, which is such a small part of the jacket. And the back panel had 95% polyester, but which wasn't recycled. So I was wondering, how do they make these decisions? And maybe we can get into a bit of that later. But what struck me the most, though, is just how complex a product like a running jacket is, which when you use it, you really don't think about it. So let's do what this series is set out to do. Deconstruct this jacket layer by layer and see how we might build it back up cleaner and without the toxins. So we're going to start with the nylon. It makes up 85% of the face fabric of this jacket and 82% of the side panels. Korcheska, can you tell us why nylon is often used in sportswear and running jackets? And why do we love nylon so much in active wear?
Just very quick history remark. Nylon was developed about 100 years ago by DuPont. It was a very surprisingly very good innovation. When nylon was first developed, the cost was more expensive than silk, and it started from women tights. So the nylon has a very unique properties as a polymer. So basically, it's very strong, but at the same time, when you spin nylon and make thread out of it, even very thin thread like 50 denier or 40 denier, it will be still very strong, unlike other materials like polyester, elastane, and so on. So nylon is one of the most strongest polymers that humankind ever created, and it has high plasticity, high quality, strength, and that's one of the reasons why it's applied so massively in the sportswear, in the high performance sportswear, especially in the brands that care about their quality and the performance.
So when we see nylon, you think, oh, it's a good thing because it performs really well and it's high quality, right?
Exactly. Yes, it's exactly, that's the thing. If you're looking for the good pants, yoga pants or a jacket, look for a content like nylon, most of it mixed with other materials.
Why is conventional nylon problematic? What is it made from? Or why should we be worried about nylon? And what happens to it at the end of its life with our conventional nylon?
Yeah, that's the thing. Like, a lot of people don't actually know that production of nylon is one of the most toxic productions in the world, and it's not really being addressed at all. Right now, all of it is made from petrochemicals. And what happens is nylon consists of two monomers. It's HMD, hexamethylendimine, and adipic acid. And one of the most toxic one is production of the adipic acid. Adipic acid is made from cyclohexanone, just briefly, and then it's used in the conventional production nitric acid. Nitric acid is used to make adipic acid. So its side product is nitrous oxide. Nitrous oxide as a gas, 300 times more toxic than CO2. And currently, most of the production of the adipic acid sits in Asia. And basically, all the nitrous oxide that released is not being filtered or abated. It's technically just released into the upper layers of atmosphere, where that gas stays about 100 years. So 300 times more toxic nitrous oxide than CO2 stays in upper layers of atmosphere, destroying our ozone layer, leads to the climate changes. So that's the problem of the production of the conventional petrochemical nylon. And a lot of companies been trying to produce it bio-based, produce it sustainably. But the thing is, the molecule is very tricky and needs really high quality, high purity to have high performance.
Wow. I've worked in the textile industry for a very long time, and I've never known anything or heard about adipic acid at all. And it's shocking to find out that was such a big part of our industry. So tell us now, how is Ozone Bio solving this problem? Walk us through your material, how it's different.
The unique thing about our technology and our process is that we are not trying to find an alternative molecule, because we know nylon has a very unique properties and you need to fit that performance characteristics and the purity. So what we've been targeting, we were trying to produce same adipic acid, same chemistry, same chemical formula, but making it sustainable and bio-based using second generation of feedstocks. So what we achieved, we actually not using sugar or food as a feedstock. We're using waste, wood bark, and nutshells. And we upcycle this waste streams using pyrolysis. And the side product of the pyrolysis is bio-oil, where bio-oil goes into our process of green chemistry. And from bio-oil, we take it all the way to the adipic acid, high purity above 98%, that goes further on into the polymerization of nylon 6X. So the way we're making it is fully emission free. We're not producing any harmful emissions except oxygen. We actually make a lot of oxygen as side product of our green process, and we're starting it from the wood waste. But we're not making anything different. We're targeting exact the same performance characteristics. So what we were able to achieve is fully bio-based out of the wood waste adipic acid, same chemistry, high purity, that was further on used for the polymerization to nylon. And our textile has same performance characteristics as a petroleum-based, but emission-free and bio-based. So that was a groundbreaking achievement for us in the last basically 3 months. It's pretty new.
That is so exciting. 2 questions here. Where do you source your wood waste or nutshell waste from? And maybe a silly one, does the type of wood or nutshell, does that impact the quality of the adipic acid and the nylon you're able to produce?
So we're located in Canada. It's actually one of our strategic locations. Canada is rich in amount of the wood waste. We're sourcing it from Northern Ontario, and we can use wood chips, we can use wood bark, whatever is leftovers in the wood processing facilities. We actually don't really care about the type of the wood. We like birch. Birch is the most useful for us, but we right now getting any type of wood. And in terms of nutshells, we're getting it also from Ontario, from the company Ferrero. They've been providing us cocoa nutshells. We can take any other nutshells except pistachio shells. It's pretty low content, lignin content in pistachio shells, but it still would serve as a feedstock. It's just the yield of the adipic acid will be lower because we're targeting lignin as a feedstock for our adipic acid in our process.
So when a product designer chooses your material instead of conventional nylon, what might feel different? You said the performance is exactly the same, but is the cost the same? Is the feel the same? Or is it almost like for like?
Quality is exactly the same, feel is exactly the same, fit the same, performance characteristics, like it's pretty much identical to the petroleum base in the standard deviation variation. So in terms, the price is definitely at the scale we're at would be higher because we're producing right now in our pilot scale only 1 ton per year. That would qualify as a premium material. However, as we scale up, as we get into the bigger production scale, definitely the price will drop. And right now, if you see what's happening, oil prices fluctuations due to the conflict, and that's always going to be the case in the world, the instability of the supply chain. And because we take targeting wood waste as a feedstock, we're quite well backed up in Canada. So the fluctuations and the price point, we actually might be, who knows, in the near future, much more competitive with the petroleum-based adipic acid in terms of the price. Depends on the price of oil, basically.
What's been the biggest technical challenge you've had to solve to make this work at the performance that is required for the industry, for example, to be used in a running jacket that we spoke about?
Yeah, we needed to, first of all, we needed obviously to work on the improving the yields of our process, because the higher yields, the higher purity eventually. So we jumped technically in the beginning of the last year, we still been in the kilogram scale, and within 1 year we jumped like to 1 ton scale per year because we were able to improve the yields of the process, and that required a lot of brainstorming and technical development. And I would say the main criteria to get into the application of nylon, because nylon is a very tricky material for polymerization, needs to be like really polymerized to the quality of very nice polymer. That was one of the innovations that DuPont made like 100 years ago. So it's a tricky polymer. So we had to have high purity adipic acid that we're talking about, like above 98%, which most of the bio-based producing companies failed to provide previously. And they never had a high yield. So yeah, so the biggest development is high purity adipic acid and high yield out of the bio-based feedstock. That was unique for us.
I mean, I guess all manufacturing processes have waste streams. What waste streams do you produce and how is that processed? You mentioned oxygen. You produce a lot of oxygen. Is there anything else that kind of goes out the door?
Yeah, we definitely, like, I wouldn't call it waste streams. So what's happening is we need a lot of wood to upcycle in order to produce adipic acid. So technically, for 1 ton of the adipic acid, we need at least 100 to 200 ton of wood waste. And a side product of pyrolysis in our case is syngas and biochar. It's actually both of these products for us right now in our current business model work as additional revenue streams. And in terms of like waste, we would have some fractions of bio oil that we do not use in our process. There are 2 ways we can address this. We either keep them and find the application, because it's a type of solvents actually that some industry can use, or they can be injected back into the ground and generate the carbon credits. So that's the waste streams that we're producing. But in terms of the quality of our green chemistry, the process is so interesting though. So one of the major waste streams would be is water and oxygen. And like I said, some of the bio oil side products that work as a solvents. And right now we're storing in the lab, and my chemists are saying that, guys, we need to start selling it because this is like a good solvents.
In terms of scale, you said you're producing 1 ton per year. When could brands really start adopting your material if they wanted to? And, do you think seeing a material like this in a running jacket, is it 5 years out, 2 years out, 10 years out? What do you feel?
No, I think it can be done immediately. So I'll give you a quick reference. So if you buy Lululemon yoga pants, the weight of that yoga pants would be around 300 grams. Jacket would be around, let's say, 400 grams. half of it is the adipic acid. It's 50% like weight. Let's say it's 85. You just said like it's 85, 90% nylon. 50% of it would be adipic acid. 1 ton of nylon, let's say, would make really good enough amount of jackets. So it's enough for the capsule production of a brand. It's also would be enough like for first limited edition of running jacket for the immediate adoption. So if we're talking about the massive application, supplying it to multiple brands, the go-to volume was for us, what we know is around 15 to 50 ton, where they would feel comfortable. Some of them are enough like to take like 50 ton per year. So I would say we're very close to that level. Our next scale is actually around 50 ton per year. That's what we're targeting for our next demonstration scale. And we're looking to start working closely with some champion brands, I would say, in the world that actually really care about the sustainability and adopting new materials very much within a year or so.
So you'll be producing them nylon as fabric, or are you working with yarn suppliers to get that made into fabric? Where do you plug into the supply chain?
Good question is that we, at first, we started with making nylon chips, nylon pallets. And we were trying to get into the collaboration with some of the brands. But for most of the brands, it's much easier to start with yarn. So right now we work on both sides. We start with brands that can control their supply chain and they know who is the yarn producer, who is the textile producer. And we also work on the other hand where we know the players in supply chain and we supply some chips, nylon 6X, nylon pellets, and they can make yarn and then out of it textiles. So that was one of the major achievements for us because we're a chemical company and it was hard for us to navigate to make a textile. But that what we've done in the last 3 months, we were able to make a polymer, we're making yarn and then textile. It's just a recent that's why we're able to present it in London in the Mills Fabrica event.
I don't know if we talked about what happens to regular nylon at the end of its life, but what happens to your nylon at the end of its life?
Same thing. What happens with a regular, basically nylon? Our nylon is not biodegradable. It's exactly the same performance as a petrochemical nylon. And if there are some pioneers in the area of recycling nylon, that would be great closed loop production. So our business is upstream. We're making it bio-based. We're not in the business of recycling that material. So if there are some pioneers or companies, I know some chemical companies that take nylon, for example, and they can do chemical recycling. And that's not startups. It's actually chemical recycling of nylon been here for the last 50 years. A lot of carpet fiber that made out of nylon being recycled in the United States. So chemical recycling is here. And if there is a way to close the loop, awesome. We're not in the business of recycling. Start doing that, but I would say we're as busy as it is upstream, trying to figure out to produce it like emission free.
Yeah, I mean, there's a startup in London, Epoch Biodesign, that does nylon recycling.
I think like also guys from Synthetica do that.
Yes, that's right.
I would say we don't really need to care about it, but if we want to close the loop, the process of chemical recycling is well established and it's actually not really harmful in terms of environmental footprint. And there are a lot of compounding established chemical companies in the United States. They can do recycling of nylon.
Where do you see the future of this particular technology in 5 to 10 years' time?
So for us, we're not only a nylon producing company. The thing is, because of the uniqueness of our technology and the opportunity to upcycle wood waste, like I said, producing wood tar, we positioning ourselves as a new generation chemical company. So what we're trying to do, and our vision is to replace conventional petroleum and oil with wood tar. It was actually the movement about 100 years ago, but then petroleum prices went down, and then all the developments in the sector of the wood tar upcycling and then producing chemicals out of the wood tar stopped. So what we're doing, we want to produce multiple chemicals out of the wood tar. Adipic acid is one of them. We already mastered that. Second chemical that we're already making is a vanilla extract out of the wood waste. We're also making some fragrances like eugenol. It's also food additive. And we already made a lot of solvents out of the wood waste, that like methanol. We're also making acetic acid. So it's a multiple chemical streams that in the case of the supply chain destruction and movement towards domestic location of chemical companies in United States or Canada, our company would be, like I said, well positioned as a new generation of future chemical producing companies. So that's our vision, one of them. And yes, first nice, beautiful hero product is the bio-based nylon, because it's been a hot topic for a lot of companies in the last almost 20 years. And we're basically the first who successfully produced a textile out of the bio-based adipic acid.
I mean, there's a real need for this material in the textile industry, and the industry has recognized that. So it's great to have you start with the textile industry. Thank you so much, Korcheska, for diving deeper into Ozone Bio. We'll now move to Supercarb, which is a polyester replacement. This jacket has polyester in the lining and across the back panel, 90%, 95% of one layer. Again, before we get to the problem of polyester, can you tell us why polyester is a very, very, very commonly used material, not just in sportswear, but in fashion generally? What are the advantages of this materials? Would you have any statistics on how much polyester is used in sportswear or fashion?
Yeah, I will give you like my real experience. So I actually worked in textile mills across Thailand and South Carolina, which is the cotton belt of America. So I've been like deeply embedded into this industry from like actual manufacturing side, like where it's produced on like weaving looms and knitting machines. And so, at those mills, like we were using cotton, polyester, wool, cashmere, acrylic. And one thing that polyester is amazing at is its strength. Polyester is so strong that it dramatically improves the efficiency and yield of all the machinery that is in the middle. When you're spinning the yarn, when you're weaving, all of the yields and the machine production rate is so much higher. So you're really reducing the cost in the middle as well. Even like at the start of the material itself, like, oil and gas is a $4.5 trillion industry. The precursor for polyester is xylene, which is a byproduct of the big oil and gas industry. It's just a $200 billion industry, okay? It's a tiny drop in the bucket for this massive oil and gas industry. And so because it's a byproduct for them, this precursor is very cheap for the industry. They're trying to basically make money on something that may not have made sense in way back in the past. Because, if you think about the history of polyester, it has existed for some time, but the boom only happened in like 1990s. So, and like over the last 30 years or so, it has dramatically basically taken over the entire market. I believe, and this is, I think, an old statistic now. I think the current total production of fiber sits at around 130 million tons. I believe that the last I checked, out of the 110 million tons reported a couple of years back, 60% of this market was polyester. And it's projected that it's going to continue to go to like 70%. So I think polyester is going to squeeze out other fibers over time, predominantly because, it's extremely cheap. Our industry loves cheap. And, it's extremely strong. So it allows all the middle processes, spinning, knitting, weaving, all of these processes to be extremely more efficient. So you reduce the cost, and then the cost of the final product is extremely cheap as well. And so that's why it dominates the industry.
Wow, I never thought about the machine efficiency as being such a big factor for why we have so much polyester. Really interesting. What is the problem with conventional polyester that we need to solve?
So conventional polyester emits, actually, the funny thing is that the carbon dioxide emissions from polyester is relatively not as big as people think it is. Actually, the impact of some of the other fibers in our industry is actually more dramatic, but because the volume of the polyester, it still makes a massive impact on the emissions in our industry. The biggest problem that comes with the polyester in our industry is because it's so durable, it is very resistant to biodegrade. Like, it does not want to degrade at its end of life. And the other thing is that the fleeces that from Patagonia that people really love, those fleeces really break down into smaller microplastic. And the problem of microplastic is so prevalent, like all four of us here have a tremendous amount of microplastic in our bodies. There's generation after generation that's being born with microplastics in our body. And so, yeah, I think to me, the biggest problem with polyester is because it's so stable, it doesn't biodegrade at its end of life. And during the use and even post-use, it continues to break down into tiny microfibers, which all of us consume in our daily life now. And, it's in our food, and it's in our body systems. And that has, the long-term impact of those tiny microplastic in our body hasn't been studied. And, new reports are continuing to come up with, of course, Europe leading with a lot of regulations around those as well.
So in the introduction, you said Supercarb turns seaweed and food waste into high-performance textiles. Can you explain how this works and what the transformation process is and how this works, I guess, as a replacement for polyester?
We fundamentally focus on the sugar part of the food waste. So basically, every food has sort of 5 components. It has carbohydrates, it has proteins, it has oil, it has water, and then minerals and vitamins. And so what we do as a company is we are only focused on the carbohydrate part, specifically a chemical called uronic acid. It's very similar to cellulose in its backbone. And one of the side chains is essentially displaced. One of the hydroxyl group is then displaced by a carboxylic group. And that basically occurs in a ton of food around the world. There's about 1 trillion fresh food that's produced. And out of that, a lot of our food is not just for fresh human consumption, which we don't touch. There's about 60%, 40 to 60% of the food that we are producing goes into industrial processing facility, depending on what food you're looking at. And those industrial processing facilities leave waste, the peels and pomaces. And those industrial waste can be then used as an input in our material, in our process. So what we do is we use reactors to essentially segregate the carbohydrate portion. So we basically remove whatever we don't need out of the waste. And that carbohydrate portion then goes under chemical modification in our wet spinning process. So wet spinning is a technology that's commonly used. It's already scaled in fibers like lyocell, rayon, viscose industry. And we use the similar kind of platform to basically chemically modify our carbohydrates into fibers. And then those fibers can then become yarns and fabrics that the sportswear industry can use.
So can you tell us some of the performance qualities of the yarns and fabrics that you're able to produce?
Yeah, so one of the unique part about our fiber is that it has inherent, these performance attributes. So if you think about polyesters and cottons of the world, these are very cheap substrates, right? They have some of their own benefits, of course. It's hard to compare, it's hard to compare one to one, apple to apple. But these fibers like polyester don't have its own inherent performances. So for example, our fiber is inherently antibacterial, antifungal, material. It also dries pretty fast. And so this allows sportswear industry to eliminate, silver-based chemistries, zinc-based chemistries, PFAS-based chemistries, which they're adding to their clothing. And so basically every single human being on this planet Earth has a layer of chemical between their fabrics that they're wearing and then their skin. And so that's basically that's where Supercarb becomes really, really strong and important because of its inherent attributes. We allow these sportswear industry to go one step beyond not just different feedstocks, but essentially allows them to eliminate cost at the finishing stage. Because when you convert polyester into a yarn and fabric, then you're putting silver chemistry on the fabric, or you're putting PFAS on the fabric to enhance its performance. So now with our fiber, the brands won't have to do that. So they're saving on the energy, labor, water, and wastewater treatment cost that would go into applying those chemicals to enhance its performance.
How about microplastic shedding? That's one of the main problems we identified with regular polyester. What happens to your material?
So our material, we've tested using ISO standards in compostable settings. It degrades into simpler sugar molecules. Because we are starting with sugar molecules, it ends up degrading back into sugar molecules. And so there is no microplastic at the end of its life. And that's like how we are solving this massive problem that is inherent to polyester.
Another problem maybe with polyester is that it's highly flammable, but I understand that your material is fire retardant, which is just amazing. So how did you achieve this?
Yeah, so what we do is we have like these cross-linkers. When our fiber basically, when you have a fire, you need three things. You need source of oxygen, you need source of fuel, and sustained heat to basically continue a fire or a reaction of fire. Because we have these cross-linkers between our carboxylates, and it converts into carbonate compounds, and it provides this layer of char on the surface of fiber. So it cuts the access of oxygen into our material. And so in the in situ way, like it does not allow our material to burn. The interesting thing about a fiber is that it does not melt or drip. You can make polyester fire retardant by putting phosphorus. Phosphorus itself is pretty toxic. California actually came up with this law called Calvin 17, then was passed by Congress as SOFA Act in US. I actually was one of the R&D engineers who was impacted by that law. And that's how the creation of this company came about. So I was working at an upholstery mill when California came out with a ban on phosphorus in the foam of the couches. And then that got adopted by the entire United States. And then in the factory, what happened was, now since the foam could not have phosphorus in it, the fabric had to do all the work. And so our reaction to that was to put more phosphorus on the fabric side so that it can prevent the fire. But unfortunately, all the natural sides continued to fail. And so that was actually how this company got created in the first place. And so the interesting part about a fiber is that it does not melt, it does not drip. And, we have a really high limited oxygen index. It's basically the amount of oxygen needed for a material to burn. So for example, polyester is around 20%. Earth atmosphere has 21% oxygen. And so we'd have to take 1% oxygen out of our Earth, and the polyester will still continue to burn. And our material has around 49%, which is even higher than materials like Kevlar and Nomex at 29%.
Wow. I was going to ask you what the trade-offs are. I mean, all these materials sound perfect, but there must be some trade-offs there. What might they be?
No, absolutely. I think there's definitely trade-offs. And the biggest trade-off for us is that our material have a higher moisture regain, which is the amount of moisture it absorbs from the atmosphere at a stable equilibrium. And that is something that we continue to work towards to continue to reduce it. The way we have seen or have positioned a material is that if you went to a trade show like Functional Fabric Fair or Performance Days, which has, very sportswear oriented, you'll see three things. You'll see polyester, you'll see nylon, which are the two massive components, and then you'll see merino wool, which is the only natural fiber that dominates this industry. And so the way we look at our fiber is that our fiber has very similar functions to wool. And, performance natural as a trend is been picking up quite significantly because of the microplastic problem with the polyester. And so our fiber is sort of adjacent to what wool can do at similar prices. And that's how we have positioned our fiber.
You talked about prices. How does your costing compare? I always understand at a starting stage when you're piloting, it is going to be expensive. But do you think you might be able to reach the kind of price points that would convince brands to adopt these solutions?
So honestly, we are working with top 10 sportswear brand already. I think the key point to be made here is that, our first target sort of in the short term, the economies of polyester work because of these massive monolithic petrochemical industries that produce this at such large scales. And that allows, the cost to be subdued to a really, really large degree. Of course, oil and gas is also being subsidized in general to a large degree. And so when we have cost conversations in the short term, our fiber is cost competitive with wool prices. And so that allows us to paint a clear picture to these performance brands because they're already used to using that material in their portfolio. And so over time, our target is to continue to be at cost parity. The second target was to be competitive with Supima cotton prices. And over a long time, as we become bigger and bigger, to then get competitive with polyester. Like, we necessarily don't claim that we will just outcompete polyester on prices from day one. Like, I think anyone who claims that definitely is going to run into some challenges. I mean, of course, there are models that work. Like, there are companies like Sire, that is an H&M in-house startup that is just doing one-to-one polyester recycling. In those economies, like, that scale could work. I mean, there's still economics unproven there as well, right? And so, not saying that this price, parity can't work in certain model, it could, but whether like we are able to actually beat the prices continues to remain to be seen. I think the best way to win in the market is to find your niche, is to find where you shine, is this find place where you beat every single performance matrix and you are competitive at cost. And once you win that tiny island, then you continue to extend your win, because otherwise I think you'll be lost.
Oh, I love that. Find your niche. That's good. Very good point. Again, a question about your waste stream. How is it processed? Is it toxic, or can someone else kind of use the waste that you've produced for something else?
Yeah, no, 100%. Like, I think actually our waste has a lot of valuable byproducts. In all honesty, like, if we were to sell some of the co-byproducts, we actually will become very, very competitive. So it has mannitols, which is used in food and pharma industry. It has fucodian that is used in nutraceutical. It has cellulose proteins. So there is, like, if you think about models of, let's say, lyocell or cellulosic industry, it is a biorefinery model, right? Same as polyester. It's a biorefinery model. Every single component of that feedstock, which is oil, is being sold to someone to substitute the price of the main product that you're selling. And so in large scale models, that biorefinery model starts to work when you sell. But the thing is, like, as an early stage startup, you can then introduce a lot of complexity into your business, right? Then you're trying to penetrate multiple markets at the same time to prove the unit economic works. And so that model does exist. And actually, like, our co-products are very valuable and we should not be throwing them away. And so because we are at a small scale and we want to prove that there is demand for the material that we are producing, it is in our interest to be a little bit more narrow focused and focus on penetrating the market as deep as possible and generating those offtakes to be then able to continue to go down the biorefinery model and then substitute the price of our main polymer.
So you mentioned you're working with the top 10 brands. I'm not sure if you're able to share a couple of the names, but what do these brands love about this material? And what have been some of the pushbacks or, kind of challenges that you faced in having them even try it out?
Yeah. So many challenges. I mean, I think all entrepreneurs and like founders in new material space will agree, like, the challenges are quite significant. I think it's pretty impressive how all these founders continue to remain very optimistic and, have like this like single focus mindset of winning. And I think it comes down to the people, like, I think all the folks in this room want to do better. And then, we have done in the past. So I unfortunately can't tell you the names because we are obligated by NDAs and material transfer agreements. The things that the brands like about us is the adjacency to wool. Wool has its own benefits. It has, it's flame retardant, it's antibacterial, it's anti-odor, it can dry fast. And we have similar sort of performance benefits without the scratchiness of the wool. Our material is extremely soft. And the base layer that you were talking about, like, it's a perfect example of where our materials can replace polyester because of the nice hand feel of our fibers. And so that has been like a really big point for us. Like, when we go into a sales meeting with a big brand, like, we tell them that, like, hey, this is the wool adjacent material at the prices of the wool with better performance benefits. So basically, like, that allows us to penetrate deep in, make the point quick, fast. In the 5 minutes, they understand where we stand. with the prices, what are advantages. We have done massive amount of testing. So we arm our brands with these testing so that they can then become our internal champions and then convince the strategic leadership that why this material is important to us. And so we have done a lot of that testing that we basically send in the few initial calls, and that allows them to form their opinion. In terms of challenges, so I would say like biggest challenge continues to remain scale. These brands, it's sort of like a chicken or egg problem that all of us face. As soon as you go into the call, they're like, okay, great, you're producing at like 1 ton or 2 ton, but we want 50 ton, right? And so you're like, great, would you give me a binding, agreement for 50 ton? They were like, oh, we want to test first, but we want you to be at 50 ton. In the case if everything goes right, we want you to be, like at scale. And I'm like, great guys, that's not how it works. And so, there's definitely a little bit of chicken or egg, but like we do understand where they're coming from. Part of like large brand is like they want to monetize on these new innovations, right? And for them to be able to monetize, they want to be able to sell as much as they can if the market picks that material up. And so in that position, if you release something or if you drop something and you don't have further to sell, then you're impacting their business model in some senses. But they also realize that like if we are at larger scale, then our prices are lower. Then our prices are actually compared like are closer to what their balance sheets can take, right? And so I think all of us face that challenge.
Absolutely. Yeah, I can definitely see a pattern from this conversation and from the several other founders that I have interviewed as well. This is very similar challenges. And I guess as a sector, as an industry, we need to figure out how to move past this because everyone kind of hits the same wall. Okay, brilliant. Thank you so much, Hitesh. That was really insightful as well to learn about supercarb. And now we will go over to elastane, which makes up, I guess, 15 to 18% of this jacket we have that we're deconstructing. It is the invisible ingredient that makes everything stretchy and recover. We love a bit of elastane in our sportswear, right? I mean, it gives the comfort and stretch that we need when we're running, yoga, walking, whatever, and even just to wear around at home. And it's always quite a small percentage that's used in products usually. Jen, what is conventional elastane made of and why is elastane a problem for the textile industry?
So elastane is kind of similarly to the other fabrics, petrochemical-based fibers. I think what was really interesting for us is that actually it also used quite toxic solvent like DMF. I recently stumbled into a website from the European Trade Union Institute that was showing a case of a Lycra Dupont company in the Netherlands in the early 2000s and how actually the workers there were affected with the use of the toxin has an effect on their reproductive health and miscarriage for women specifically, etc. Which, of course, in a few months afterwards, the company, like the plant, completely closed in the Netherlands. But then, actually, because that's Europe, but like I can't imagine if it's continued to be the same case around the world. So I think that's why I really enjoyed the Nels Fabrica exhibition because there was a big focus on the toxicity part of the people working in those factories, but also more and more there's been kind of proof of the impact of synthetic materials on our body and our skin and what it can have in the future on us right now and then further along with microplastic, as Hitesh said. So I think that was kind of, the big problem with elastane we found on the kind of toxicity part and fossil fuel-based dependency. And then what we found super interesting is the fact that this, as you said, the small fiber, there's a bit the hidden villain in the industry, just blocks everything to be recycled. So when an industry wants to move to circularity and wants to move about better end of life, there's just this fiber that blocks everything.
Wow. I mean, it's so ironic, isn't it? Here you are making sports clothes and activewear for running out in nature and being healthy without just realizing how toxic that running jacket is. Yeah, that's quite worrying. So, I mean, that's why I love the exhibition at Mills because, just for the daily, everyday consumer, they can walk in and just learn about the clothes that they wear, the products that they use, and why the industry needs to change. And that can hopefully drive the consumers, the awareness that they have can drive the consumers to push brands to make the changes as well. Why is elastane so hard to replace? And what is the solution that Terramera has developed? And how is it different from the petroleum-based elastane?
So I think elastane is difficult to replace because of its performance. I think right now you can have some different elastane that can go up to like 400% stretch, for example. But then sometimes we believe it might be sometimes a bit too over-engineered when you look at the way you can sometimes have a normal, comfortable stretch with about 40% stretch or 50% stretch. So yeah, I think it really depends on the application it has, and therefore the way it's knitted as well. So there's a big factor on this kind of stretch, but also the recovery, which is very important. And then more and more, there's this trend, I guess, on like four-way stretch. So making sure, especially for this fleece jacket right now, it's being able to have really this that you can stretch on the horizontally and vertically, and it brings us more comfort for the people wearing it. And then, I think that was kind of more the performance aspect. But actually, what is interesting with elastane, plus the fact that it's impossible to recycle, is that it's very hard to dye on. And so a lot of brands, for example, would cover it with cotton above it, polyester on it, and that brings more cost, that brings more energy. Or then there's more innovative that coming up with being more color absorbent, but it's a kind of a new system. And I think when we look at greener alternatives right now in the market, elastane is really mainly dominated by three big players that are making bio-based alternative, but these are still 60% derived from petrochemicals, and 40% are using land-intensive feedstocks like corn or sugarcane. I think there's one of the competitors at the Mili Tharakan that was actually showing that they now found this 90% sugarcane bio-based fibre, which is, I guess, great because they're all making more efforts as well. And then we found out that there's a bit more new e-commerce of elastane, but more for specifically niched. For example, there's an Italian one that's focusing on elastane for denim, and they're using, for example, 100% natural rubber. But for example, natural rubber, we know it's very linked with deforestation and child labor, and it was in the EU deemed as a critical raw material. So I think there's been lots of efforts towards that, which shows a good sign. And also when we look at all the seaweed-based fibers, they've been amazing at having the softness, but they're not providing the stretch. So what we found was to really try to create the first fully bio-based alternatives to elastane with seaweed. And the way we're competing and the way we want to differentiate is from our feedstock, but also from the way we're spinning our fibers. And so the feedstock is going to be looking at seaweed. It's a highly renewable feedstock. It doesn't require land, fresh water, fertilizer. And what is interesting is that it's very everywhere in the world. So, for example, we see a lot of, I'll come back to that point actually in the second point, because it kind of links to my second point. And now we knew that it was not about creating a new machinery and a new factories, but it was really about plug and play. And that was the most critical thing that we've heard from brands, etc. So we've managed to completely 3D printed a lab scale spinning line that mimics the industry scale one. So we could continuously iterate our formulation to fit within current systems. And so that's why it's working right now. We have a good prototype. So we're only 1 year old and we have a good prototype that meets this kind of comfort stretch performance of about 70% stretch and 90% recovery. The way we envision kind of Terramera is to be able to really have a resilient supply chain based on the brand's supply chain. So for example, if a brand wants to add its whole manufacturing in India, they're using cotton, Indian cotton, and they want to be able to add elastane. Right now, we're doing some more research on Indian seaweed, for example. And the spinning line that we're using is very the same one that is being used for acrylic or viscose. And so if we can look at, I know India is producing a lot of viscose as well. So if we can look at one of their fiber producer and kind of creating this seaweed to fiber hubs around the world, that's kind of the way we want to be able to compete and differentiate and create this kind of resilient supply chain that follows natural cycles, but also kind of isn't too far away from the global complex supply chain that is fashion right now.
Why did you choose seaweed?
Yeah, seaweed it's been proving that it's an amazing feedstock compared to to plastic. I think this is getting more and more traction. We were looking for a feedstock that is quite close to home as well, and right now we had some connection with seaweed in Scotland and in Ireland. So that was kind of something that made sense for us that way. And the fact that it's kind of be found everywhere and that has the properties that we're interested in.
And have you done tests and certifications that can help brands feel more confident about the yarns that you've developed, or you're not quite there yet?
Yeah, we're not quite there yet. So we're 1 year old. We've managed to create a first prototype, so we're quite happy about it. And then in May, we have a pilot planned and funded with an industrial scale spinning line. So the moment we can prove that what we've done in the lab works in a industrial scale spinning line, then we can start doing the proper certifications and we can properly start testing it. And it's something that we're going to be doing kind of simultaneously from the pilot to kind of see changes in our composition or getting that feedback look in a sense. But yeah, I think it's also interesting to look at all the different certifications. It's a bit sometimes confusing when especially with elastane. I don't really know how. I mean, I'm doing a bit more research on it, but it's a bit, it's a bit of the.
And you said it's a material that really clogs up the system when you're trying to recycle it. What happens to your elastane at the end of its life, and if it's in a product?
So right now we haven't tested anything regarding end of life as well, but we're really designing it to be compostable. Home compostable will be kind of the dream. I think that's kind of, we're looking specifically at a market like underwear and sportswear. And these two markets, we know they're not going to be bought secondhand and people just will put it in the trash and they're not going to be recycling it or buying it secondhand. So that's why I think it was something we were really interested in. Right now, there's so much factors that we need to take into account to make a clothes compostable. And that means the way it's blended and then the way it's been dyed on and what are the other finishings that was been put, because even if you put the most biodegradable fibers and you put the worst finishing, then it doesn't work. But then, so that's kind of like the first option. But then we know, for example, for sportswear, lots of brands were interested in recycling polyester, for example, from their legging or maybe from the fleece or like the nylon, but the elastane blocks. And so we're trying to find a way maybe to decompose the elastane so that the primary textile can be recycled. So I don't think our fibers will be recyclable. It's a bit too hard to push for that, but at least that it can kind of take off these barriers, decompose within chemical recycling, and then the primary textile to be recycled. So that's kind of what we're envisioning.
And where do you see your technology in sort of 5 to 10 years' time?
Yeah, I guess because right now in our kind of roadmap, we'll start with having a small pilot line in our lab just to continue iteration and sell the fibers. But then we want to start partnering with a fiber producer and kind of do tool manufacturing where we can kind of rent the machines to have a control on the fibers that have been produced and kind of create a ingredient branding. So kind of following a business model where you want to say that you've made this fabric with this specific fiber and kind of create and control the IP around it. And then when this is done, or when this has a bit more traction, then we want to move into a licensing model where we will just have to license the formulation to existing wet spinners around the world and can produce the fibers for us in a sense. So it's really just being a bit more I don't know if it's even a word, but like a formulation magic recipe maybe a chemical company in a sense, but like a bio-based chemical company. But I think that's going to be looking at elastane and then playing with the whole world of elastomers. There's so many different applications also outside of fashion. But right now, where the need was the most was in fashion, I think we found. Yeah.
Right. So are you working closely with some brands? Have you been in conversations? What's been their interest or reaction?
Yeah, I think we're working with, there was a lot of customer discovery and a lot about making sure what we're doing is really needed, because I think we were like, are we ready to kind of embark ourselves in this journey? We wanted to make sure it's worth it in a sense. We're speaking to a lot of brands, but also Mills, interestingly, they really want to now have a bit more of a say within the supply chain and provide new solutions to brands. And so, I think it's interesting depending on the market, what their needs are. So like sportswear, they're going to be looking at recycling the materials. Underwear, they're going to be fully focused on making something compostable. And making sure it's still soft and the stretches and the performance requirements as well, what is needed. And then the benefits that maybe our fibers can add in terms of dyeability and breathability. That is also quite important for the underwear and sportswear industry. So,
And I guess like you mentioned, nylon sort of always, mixed with another material, another fiber. So have you thought about sort of bio-based nylon, as we mentioned here, or the polyester replacement from Supercarb? Have you kind of had conversations or thought about how you work with new biomaterials that are being developed as well?
Yeah, totally. I mean, I think sometimes we ask brands about this as well, if they are in touch, so that we can understand, for example, if we have similar supply chain. So, for example, even if Lyocell or I think anything that is kind of formulation based, if they have the same, if they're using the same spinning line than us in the end, if there's a way we can connect and kind of create the fabric together. Because sometimes as the yarn level, you don't have as much value in a sense that if you are a fabric or if you're a brand, that's where most of the value is in the winning supply chain. So if you can come stronger together, it's kind of easier for adoption for brands. So no, definitely we speak with a lot of brands, but I think it's creating also the right story between the two companies and making sure that the right stage, where it's still very early to kind of try anything like this. So right now we're just trying with cotton, for example.
Thank you so much, Jen, for that introduction to Terramira as well. So I think the exhibition really succeeded in showing was all the ingredients that need to come together for the full life cycle of a sportswear. If that running jacket in the future is going to have all three of your materials in it, how do we get to that point? I mean, you sort of mentioned a little bit to that, Jen, just now, but how do we make sure that all of these ingredients come together into that one product? Korcheska, your thoughts on that first?
As I mentioned, probably that would be combined efforts from both ends, supply chain and brands as well. So that should be commitment of the brand to adopt that kind of material, and the supply chain willingness to change that, because it does require a lot of equipment, sometimes installation or different sizing of that equipment, and the commitment on the several players in the supply chain. In our case, it would be polymerizer, spinner, and the weaver that should commit in that. And then upstream, that would be brand adoption.
Hitesh, how do you see all three of the materials that we discussed today coming together? How will brands coordinate that?
Honestly, it can be done. Of course, textile industry is very interesting. Material suppliers are more monolithic, and they're very big. Yarn industry is very fragmented. Fabric industry is pretty fragmented. And then you have brands, which are, again, there are a lot of brands, but then there's only few monolithic brands that can actually drive the economies of scale and try to bring these materials together. And so for, Ozone Bio, Terramira, and Supercarb to come together, I think the best would be to get embedded into the supply chain where they're already used to buying, right? If what usually ends up happening for these sportswear brands is that they are buying from the same factory. It is kind of a secret that everyone knows is not a secret. And so a fabric manufacturer that already has a base layer that's made from Supercarb, has jeans spandex in it, and the face fabric from Ozone Bio with nylon. If they have it at one place in the same supply chain that they used to buy, that becomes much more easier to bring together and adopt. And I think that is most of the material innovators need to focus on embedding themselves into the supply chain that these brands are already used to. That being said, a part of that intention to bring these materials together also comes from brand. So actually, Peak Performance brand actually just came up with their helium down jacket with, they use Burroughs recycled nylon. And then they use Resortex, polyester that can melt away. So, when the brand intention is there, sort of say that hey, this is what the future product look like from feedstocks that have never been used before or are upcoming. If the intention is there, then these materials can make it. And the way we as innovators can facilitate it is to get embedded into the companies that they're already used to buying from. That's the fastest way to penetrate this market.
Yeah, I completely agree with that. I think if we could find this one mills that wants to all try us up, and I think there are some that are trying to now kind of adopt all new innovation, provide them to brands. and then come with a already supply chain ready for brands to copy, or like, I don't know, like to try us in a sense, and kind of scale up that way.
Because I feel like brands are trying out different pieces of the puzzle and in a smaller way. But if they kind of brought a group of you together and figured out, oh, for this one jacket, these are the materials that we need, who can we bring together and pilot with for that one product all the way, I think that would be really interesting.
Even I was interested into like you guys byproduct. You were saying that you have lots of byproduct from the production line. It could be super interesting even for us to test in some of like, because right now we're testing a bit of byproduct from the seaweed used in biostimulant. But like if we can tap within existing supply chain that way and kind of, I don't know if it means creating a codependency, but in some ways more about the scaling together, and then maybe creating a solution for brands with the two of us that kind of like are auto, like, in a kind of regenerative way, or I don't know, kind of like collaborating together. But yeah.
Absolutely. I think collaboration is definitely the key. And I was curious to find out if any of you were collaborating with any of the other exhibitors from the Performance Without Toxicity exhibition. It's totally fine if you're not. I know everyone's sort of focused on trying to get their product up and running, but I was curious if you were.
Not so much directly in like one-to-one collaboration, but I'm connected with a lot of folks from the Mills Fabric exhibition, and I have made commitments to introduce them to the brands that we work with, and I think especially like getting a warm intro directly to a brand, to a person who is actually looking into adopting these materials, is the best way to penetrate the market as well. It can be really difficult to like actually figure out who is the right person to talk, because these brands can be massive. And the crazy part is that there's only few folks, like two folks at these massive brands, that are making all the decision. And so we regularly work with innovators and introduce them to our investors or to the brands they're working with, and they do the same for us. And I think we understand that like we're not technically competitors, more so like collaborators in this really long journey, because this is going to be a pretty long journey to bring these solutions to market. So yeah, I think we collaborate in that way, but not so much that, let's put both of our materials together. But hopefully with this podcast, we get inspired to do that.
Excellent. So looking ahead 5 years, do you think a running jacket made entirely from non-fossil fuel materials performing at the same level as today's petroleum-based version is realistic? And what has to happen between now and then? Is it regulations? Is it brands being braver? How long do you think it'll be before we see your materials on a label? Francesca?
I think it's realistic, at least based on the composition content that you just mentioned. If it's a 95% or 90% nylon, we have enough material, and we're at the reasonable scale right now to provide enough material to supply capsule edition, or quite a bit of amount of material to have to make at least 1,000 jackets. Or I would say 2,000 easily. We can, even at the scale we're at, and we're at the pilot scale, our next scale will allow us to produce several thousands of jackets. So we will be able to provide enough material as long as there is a need in the consumer-facing market. One way or another, we'll make it happen, like I tell always to my team.
Yeah. I love that optimism, and you need that, absolutely. Hitesh, do you feel that strongly, that in the next 5 years we'll see your materials on the label?
Yeah, 100%. Like I think we have already made yarns, fabrics. We have supplied fabrics to like global companies across the world. So like we are at that reality now. We might not be at the scale that you wish millions and millions of people wearing our material and our material showing up on the labels. We might not be there now, but the reality of whether we can substitute it now, it exists. Those fabrics exist, we supply them, and you're actually going to see more product releases. Like we actually released our first garment at the Mills Fabric exhibition, which was a legging, to show that like this future is present, and that we're creating the future now. And you're going to actually see this year multiple releases from our company of these products, and I'm super excited, honestly. Like there are multiple ways to create a future, And, I am very mission driven to create a future that I believe in. And I believe there is a critical mass of people that believe in the future as well. And then the intention is there. And so we're going to continue, getting there with full force.
Excellent. And how about you, Jean? How do you feel in 5 years? Do you feel we'll see more of your materials out in the market?
Yeah, I hope so too. I mean,
Yeah.
I think it's the big dream as well. I think if there's you were asking if there was other players to be part of, and I think right now the EU regulations are getting kind of accelerating. I feel like we've recently even the ban on destruction of unsold goods or EPR that's getting it. So maybe I feel like maybe the US is doing also a few changes. I've seen some new laws coming up. So I think there's generally maybe if this can be a money spent or paid from brands to be kind of reallocated to innovations, or I don't know. I think these regulations could have also an impact on that. But yeah, I think and consumer demand. I think there's definitely a change showing up right now more and more from social media and stuff. So I think it's pretty optimistic, yeah.
I love it. That's what we need. We need optimism here and confidence that we can change things. Excellent. So now we're going to shift gears slightly. I'm aware of time. If you can just spare me 5 more minutes, I have 3 quick questions. So just to reflect a little bit on your experience as, or founders, CEOs of upcoming startups, really disrupting your fields. Are there any favorite failures that you've had, projects that didn't work, experiments that went horribly wrong, but it sort of ended up opening new doors or ideas and unlocking opportunities as well? Hitesh?
This is a tough one. I have to admit. There's been so many failures. I think in our journey, we got really close to getting a really significant agreement with a really large sportswear brand, and we spent a ton of time on the legal back and forth. And unfortunately, at the critical last moment when the signature was going to hit the agreement, that didn't come through. And I think I would say that's probably one of the biggest failure. It's one thing to actually create a technological breakthrough, and it is a completely different thing to actually commercialize a material. Those are two separate games that you are playing. It is a completely different ballpark. You are so out of your depth at these massive billion-dollar companies that are sitting on the table with you. You don't have the leverage to actually be able to push them around, or it's not just push them around, but to have any sort of leverage over them in the room. So I think for us, the biggest learning from that was basically that we need to continue to de-risk the way we operate within the ecosystem. How we think about sales, how we commercialize, who we commercialize with, there's to be a lot of thought put into it. A lot of time, founders are told that you have to have just plan A, because if you think about plan B, then, you are going to fail on plan A. I think that is a little bit bullshit, to be honest. I mean, it's I don't think it's a great advice. I think in commercialization plan, you have to have multiple partners, multiple options, multiple, players that you're working with to de-risk your commercial strategy, so that you don't end up in a strategy or a place where someone walks away and then you're like, oh, what do we do with the company next, right? And so, yeah, I would say we have gone through that, and I'm glad that I've had that experience early. Thanks.
Yeah, I think we were told a lot of time about this famous guy that lives in the island of Scotland that he knows everything about seaweed and he's the seaweed expert, and he just never answered our emails or calls. So my co-founders just went to do a camping in Scotland and then knocked at his door. And I think that was kind of for us, that was a bit of the mistake of sometimes thinking a bit outside the box and being okay, going a bit more the old way, creating connections, when it was about securing that knowledge that we don't have it as first-time founders. So yeah.
For us, it was actually that time, 2 years ago, it would considered maybe a failure not to signing the deal with multi-billion-dollar company. But right now, actually, after several years and the lessons that market provided to lots of companies, they've been in startups that been in touch with such multi-billion-dollar conglomerate, and actually that failed them. I would say it was great thing that we didn't sign for it and we went on our own path. And right now we're free and independent and we can sign a deal with multiple other players. So yeah, that's it.
I mean, gosh, you are really trying to do so much at the same time. Like Hitesh mentioned, you're not just developing a new technology, you're trying to commercialize that. And that's a whole other ball game. And it's blood, sweat, and tears every day for a very, very long time. I'm really curious to know how you take care of your health and well-being while setting up a startup that is really just starting to grow. There's a lot of momentum and there's every day it's just action-packed and you're raising funds and changing the status quo. How do you take care of yourself in the midst of all of that? Korcheska?
I'll be honest, I don't take care of myself. So I'm still trying to, use the fuel that, young ages are still giving us. And me and my co-founder still on that fuel. But I think we have maybe couple more years, but then we have to start taking care of ourselves. So I'll not be saying like, oh, you know what, I do sports and then stuff like that. And, and then I take my smoothie in the morning and all that. No. Yeah, we're just mission driven. We're hardworking. People will like what we do, and we actually sometimes in a position where we're really close to psychotic state, but it's all right.
Yeah, absolutely. I mean, that is the reality on the ground, isn't it? You just got to show up and handle things. And this is the season that you're in. Hopefully not a never-ending season, and you will get to pause and get time for yourself as well. Jin, what about you?
Yeah, I mean, I think I've been kind of also struggling to find a balance. And I think what works for me right now is just taking one day in a weekend where I don't leave I just don't put any schedules in to meet anyone and just spend alone, in a sense. Or maybe spontaneously we'll call someone to meet a friend or a family member. But like just because during the whole week you're so booked with so many responsibilities that then even when I would book myself something in a weekend, then I would like completely panic about actually going to that place. Because I was like, I just want to stay in bed. So I think I had like this high and lows, and I'm trying to kind of balance this a bit more. But I think accepting that at least once a week I need just to stay in my bed is already a good progress, I think, for on my side.
It is such hard work. I mean, what you guys are doing is amazing. And from the outside, it might look very glamorous to be a startup and it's, kind of in the right crowds and fundraising and all of that. But it's hard work. And people need to know that you're sacrificing so much because of the vision that you have and the mission that you're on. Hitesh, do you keep a sort of sane, balanced life, or is that a dream?
I mean, it is still a dream that I'm chasing. Like, I think the first year I started, I would work every weekend. And that was like, in second year, I was like, okay, this is not sustainable. Like this, you just can't do this. And so I think the second year, like now we're in the third year, like what I found really good was that I started climbing. So I'm a rock climber. And what climbing does, it allows you to create these short wins. And so when you're solving a bouldering problem and you're going through these grades, it allows you to create these short wins and you can then take the energy back into the marathon that a company is. And so honestly, like I think climbing is one place which disconnects me completely from my work, because like when you're on the wall, like you have to disconnect. Otherwise you're going to fall, right? And so I think that has kept me sane, honestly. I am so thankful that I kind of discovered that. And
That's lovely. And it is so true. Short wins from anywhere. It is the fuel that helps you to keep going on that long marathon that you have ahead of yourself. All right. The last question, and it is my favorite question to ask all my guests. I hope you enjoy it too. So we've been talking about textiles as a very functional material, but it is much more than that. Fabrics fulfill our senses and our soul, and we engage with textiles in such an intimate way from the day we were born to the day we die, right? So could you share with us about a piece of textiles or a garment that holds deep personal value or memory for you, something that you hold on to and you feel real strong connection to? Is there a personal story that you can share with us before we wrap up? Korcheska.
I actually have a piece of a textile that was prepared by my grandmother, and she was like doing some knitting on it, on top of it, and she like created some sort of like a piece of art there, which is a golden bird, and she specifically prepared it for me. So I would say that would be a piece of fabric that I have a connection with.
Yeah, that's beautiful. Thank you. Hitesh?
Yeah, I think for me, it's a blanket. Like when I moved to States, my mom gave me this blanket that her sister had given her for me. And I think I've had that for like last decade that I've been in States. And so that's pretty personal for me. I carry it around. Sometimes I take it to camping as well. It's nice and it's warm. So yeah, that's kind of mine.
Absolutely. Very comforting. And Jean, what's yours?
I actually never really had a teddy bear, but I had a piece of like square kind of cotton. And what I always loved was the smell of it. And then the smell of home, of the bedroom, or like if you had a hug from your parents, then the smell of the perfume of your mom would stay on this kind of cloth. So I think I'm trying to keep these smells on, and I always just lock it in somewhere, and I hope it's not going to now start smelling. But I think it's just piece of cloth is so, I don't know, with time got softer as well somehow, and get all these mixed smells. And I think that's kind of when I need to, I don't know, think back about time or be a bit more nostalgic. It's kind of what I always go back to.
Oh, beautiful. Thank you so much, guys. There's such beautiful stories. It's nice to kind of root all of that technology and performance back to something that we really connect with personally. Different kinds of materials that we have in our lives. I can't tell you how inspired and how much I enjoyed this conversation with three of you. I wish I could have spent an hour and a half with each of you, and maybe we can have you back on your own, in a year or two when you're really in a different place with your company. But really, really inspired by your commitment and your passion for what you're doing, and to really change things because you want to do things differently and leave the world a better place than what you found it to be. So thank you very much, Hitesh, Korcheska, and Jean, for your valuable time and sharing with us your personal story about each of your companies and what you're doing to radically transform the textile industry.
Thank you so much, Mili.
Thank you, Mili.
Thank you, Mili.
What an incredible episode that was. I mean, each of our guests were just so passionate and committed to change how performance wear materials are made and what they're made from. I mean, I love it. Great conversation there. So we've started to rebuild our running jacket from the inside out. We've replaced the nylon, the polyester, the elastane, all the fossil fuel backbone of performance wear with materials born from waste streams, renewable feedstocks, and green chemistry. But fibres are only the beginning. In the next episode, we'll be hearing from innovators developing toxic-free solutions for the finishing and construction of our running jacket. These are the hidden layers of chemistry that most of us don't even understand or even think about. The dyes, the water repellency and moisture wicking treatments, and a lot more. Because even the cleanest fiber can be undermined by toxic finishing or designed in a way that makes repair and recycle nearly impossible. Hit subscribe to make sure you don't miss the next episode in this series as we continue the journey of this running jacket. Clean Run is a companion series to the Performance Without Toxicity exhibition that is open until 26th of June 2026 at Fabrica X in London. I've popped a link in the show notes for you to find more details. Do visit the exhibition if you get a chance. It's a free exhibition. Genuinely, it's worth your time. You will walk away full of ideas and inspiration. As organizers of the exhibition, here's a quick word from Amy Tsang, head of Europe at Mills Fabrica, and Yumi Ito from Goldwyn, the leading Japanese outdoor and performance wear brand, sharing their thoughts on why this was an important and timely collaboration.
I'm Amy Tsang, head of Europe at the Mills Fabrica. We're a global innovation platform dedicated to supporting innovations across the textile and agri-food industries. We have an investment fund, co-working spaces in London and Hong Kong, an innovation gallery and concept store called Fabrica X, where we host exhibitions, and finally, we build strategic partnerships to accelerate sustainability across industries. Our latest exhibition in London, titled Performance Without Toxicity, is exploring a new paradigm for performance wear, one where technical excellence no longer comes at the expense of people or the planet. Today, performance wear relies heavily on synthetic fibres and chemical treatments to deliver stretch, moisture management, durability, and weather resistance. But these solutions often come with considerable environmental trade-offs. Through this carefully curated exhibition, we're showcasing 37 companies that are advancing a clean, circular, and regenerative path forward for the industry from all around the world, spanning early-stage startups to commercialized innovations and global brands. The curation has been supported by Goldwyn, our lead innovation partner, a Japanese performance brand that integrates research, design, and investment to advance the future of apparel and material systems. Performance without toxicity is guided by 4 key narratives: reimagining materials, performance without petrochemicals, greener chemistries, beyond durability, designing for circularity and longevity, and finally, future footwear. For anyone curious about where performance wear is heading and looking to discover some of the solutions that are making activewear better for the sake of our planet, then this is the exhibition for you.
My name is Yumi Ito. I worked at Goldwyn Inc. and I am also part of Goldwyn Players Fund, Goldwyn's corporate venture capital arm. Goldwyn is a performance and lifestyle apparel company. It was founded in 1951 as a knitting factory in Japan, and soon after shifted its focus toward sports apparel. Our origins lies in skiing, designing garments for snow, cold, and extreme conditions. Over decades, we have built deep expertise in product development, working not only on our original brand, but also operating and developing leading outdoor and sports brand in Japan, including the North Face, Harry Hansen, and some of them we are holding their trademarks domestically in Japan and developing products through our own design and R&D capabilities with a unique retail strategy. This experience has shaped our identity. As a company rooted in sports and outdoor fields, we believe our true field is planet itself. For us, reducing environmental impact is not an art project. It's inseparable from our responsibility as a company that designs for life in nature. So we support startups and technologies that can help transform the apparel industry towards a more circular, regenerative, and responsible future. The theme of this exhibition felt like a very natural fit for us as a company, which is why we were excited to be part of it. We've always loved how the Mills Fabrica supports innovators through exhibitions like this. It's something we've admired for a long time, and in many ways it reflects what we also hope to do through our own activities. So we are truly happy to have had the opportunity to collaborate on this project. It also connects directly to one of our company's visions, to harness boundless imagination and employ innovative approaches aimed at fostering a healthier planet. Collaboration with Mills Fabrica is another way of supporting and bringing that idea to life. At Goldwyn, our approach is to making product is closely connected to improving the global environment. We see our product is not only as items people use, but also as a way to better understand the planet. Almost like a medium that helps spark dialogue about our relationship with nature. Rather than focusing on prototyping alone, we place a strong emphasis on turning new materials and technology into real product that we can actually deliver to customers. In this exhibition, you can see several tangible examples of that, including products developed in collaboration with our corporate VC's portfolio companies, such as Influx, Bioworks, and Soracor or Fibre, that has already reached the market. Of course, developing new materials or technologies takes time, but we believe it's important to introduce these innovations to a wider audience through exhibitions like this. By sharing these efforts, publicly, we can also communicate the direction Goldwing is aiming for. At the same time, we recognize that we are not a company with the scale to transform an entire industry on our own. That's why supporting communities like this, collaborating with other companies, and creating opportunities for dialogue are so important to us. Through these kinds of collaborations, we hope innovative materials and technologies can gradually find their way into real-world application.
As Yumi mentions, reducing the environmental impact of their product is not just a side project for them. It's inseparable from their responsibility as an outdoor wear company. And I wish more companies, not just performance wear, but all companies would really start thinking like them. She highlights the importance of the need for dialogue. And this exhibition really does invite people into a conversation and encourage collaboration. And really, this is the only way we can transform the landscape of outdoor and performance wear. If you enjoyed this episode, please leave a review and share it with someone who'd find it valuable. And if you'd like to support the podcast, there's a link in the show notes to buy me a coffee. It goes a long way during those late night editing sessions. If you have any questions or feedback, please contact me. All my details are in the show notes below. And I'd love to hear from you. Thank you for joining me today. Until next time, I'm Mili Tharakan, reminding you that there's no such thing as ordinary cloth. Every thread tells a story.